Okay, you have a formula that creates this. Okay, let's say a formula, an equation that creates this. This is x, this is y. Now, this was, for instance, Newton's law of gravity. Newton's law of gravity, the prediction was like this. So basically here is where GR kicked in.
Deviates, yeah.
Yes. So till here it's almost same. Here is same. Between Newton and Einstein there is agreement like as much as you can measure or observe.
Low gravity or
yes, low gravity you cannot even find about any difference here.
Newton physics is good for us on the surface of the Earth. It's okay.
Exactly. Here GR could explain till here.
So
you understand what happened?
Light.
What is here? Here is black hole. Here is dark energy. Here is dark matter. Cannot. GR finished here. This is the limit of GR. Done. So the problem with equations is this. When you are talking about universe scale, then it fails. When you talk about infinite gravity, not infinite gravity, like black hole gravity, it fails. So basically, this is the problem that happened exactly to Newton's law of gravity. Now we are here. But who dares? Doctor, you tell me, even your face not here because I think you are not daring yet, who dares to question Albert Einstein? I dare. It doesn't matter. I'm making fun of myself. It's fine. It's finished here. Right? But the problem is no one dares to question it. Now, again, we have the same situation with quantum mechanics. Quantum mechanics equation, first of all, the logic behind that is very questionable. And they are predicting, for example, let's say, certain effects here. Okay? And everything works. Suddenly here, you have double slit experiment with quantum eraser, it doesn't work. This shows the equation was good enough till here. Not after that. You know what I'm talking about? The equations are right, the experiment is right, but it doesn't work here.
Yeah.
Therefore, you should go back again to point 0 and define everything again. Because the problem started from here. The problem doesn't start here. It doesn't start here or here. The problem started at the beginning.
Yeah, but new theory should go into the old theory at the right limit. Yeah, this is what
and it will. Like this QTT, what it does, it has the same calculations. Like the same result of the calculations, not same equations, but the result will be almost similar unless in extreme situations. Because in gravity of galaxies, the space-time curvature will not cancel each other. They are subtracting Fabrikas altogether accumulatively.
Maybe that will happen at large energies, large gravity.
Yeah. So the calculations in the extreme situations will be very different.
Yeah, no, of course.
So suddenly here we will have completely different result. Two equations are similar to each other in the matter of number, like gravity of Albert Einstein and gravity of Newton. They give you almost similar result until you reach to, I don't know, 90-something% of the light speed and things will be different or very large. So we need this to redefine everything. Not trying to just solve the problem here or here. We should solve the problem here at the beginning of defining everything.
Yeah, that's a hard part.
It's not hard. Doctor, I will tell you something. This is not hard. I can actually work on the equations, but it will take a lot of time. For you, it's very easier, okay? Because you are a mathematic man, okay? And you know exactly what we are talking about. Come up with the equations, please. Let's do it together. We are gonna actually have a lot of fun by predicting some things that observe by Hubble, and we can have access. We don't need even to pay money. I think NASA is publishing Hubble results pretty free, and we can actually start working on that and explain things.
Yeah, we have to just start how to write equations.
Yes.
I'm trying to complete picture.
We can actually discuss this more tomorrow again. And what we can do tomorrow, we can actually start watching more about other interpretations.
Just